All right, class, today we're going to be looking at one practice problem to review what happens when I divide or multiply by a negative number with my inequalities. And then we're going to take a look at some compound inequalities after this. So we're looking at problem number 12 on page 20. Actually, let's do 11 and 12 on page 20. So when I'm trying to solve a problem here and it requires me dividing or multiplying by a negative number, I'm going to have to flip this inequality. So for this problem, scroll down a little bit, I am going to have to divide by a negative 14 on both sides of my inequality. And because I have to divide by a negative 14, usually change the color. I'm not sure if that's showing up very well. Because I have to divide by that negative 14, I have to first, as soon as I get that division by negative 14, I'm going to change the inequality so I don't forget. So what had been greater than or equal to is now less than or equal to. And then negative 14 divided by negative 14 just leaves me with z on the left. And negative 70 divided by negative 14 is a 5. And then I can go ahead and graph my critical number. Since I have a line underneath my inequality, I'm going to graph this as a closed circle. So I want to make sure I fill in my dot completely. Make sure that you can tell that it's a filled in circle. So that includes my 5, and then I want my variable to be less than 5. So well, that's not a very good shading, but it'll work. And I am remembering to shade in my arrow as well, indicating that my answers will keep on going. So all of these shadings are just me trying to represent all possible answers in my answer set. So 5 is a possible answer. That's why I filled in the circle. And then everything to the left of 5 or smaller than 5 will work as well. So if I put in a 0 here in my original, negative 14 times 0 is going to be 0, which is greater than a negative 70. So 0 is greater than negative 70 is what I will get, which is a true statement. So everything 5 and below will work. So let's go ahead and take a look at number 12. Now, number 12, I have a couple of different options. I can divide by a negative 1/4. That's what operation I have here. The operation that I have here would indicate that I was going to divide by negative 1/4. But that's not really the easiest option. The easiest is actually to take this and multiply both sides by my common denominator, which in this case I only have one denominator, so whoops. That common denominator would have to be 4. Like I said, it's my only denominator, so I only have the one option. So if I multiply this by 4, I have 4 times something where I'm dividing by 4. So those will get rid of each other. Opposite operations. 4 and the dividing by 4 will get rid of each other. Now be careful, I haven't done anything to get rid of my negative sign here, so I'm still going to have a negative 1k on the left And I haven't done anything to divide or multiply by a negative number yet, so I'm also still going to keep my less than or equal to sign for now. And then -4 times +4 is a -16. So this was me just basically getting rid of my fractions so that I can move on with my life in this problem. So again, my multiplying by 4, dividing by 4 ended up canceling each other out. They ended up just becoming 1 together. So 1 times -1 gave me a -1k. Now, in order to finish solving, I'm going to have to divide by a -1. And I'm going to do that to both sides. Divide by -1. So then I can get k. Now that I've divided by a negative number, I need to flip my inequality. So instead of a less than or equal to sign, I'm going to have a greater than or equal to sign. And then, so k is going to be greater than or equal to 4. Sorry, I looked at the wrong line, 16. So -16 times -1 gives me a +16. Now, I could have, if you want to even simplify this work for yourself a little bit more, I can divide up here by a -4 and basically do all of this work all in one go. So if I multiply by a -4, not only am I going to get rid of my denominator, I'm going to get rid of my negative sign on the left, so I'll be left with just k. And then over here, if I multiply by a -4, -4 times -4 gives me a +16. And then because I'm multiplying by a negative number, I would flip my sign. That's kind of a lot of work to do for one step. So if you just want to take care of your denominator first, get rid of your fractions, and then multiply or divide by your negative number, then I will have a little bit clearer path, even if it did take me just the one extra step. So then I'm going to graph my critical number of 16. This is greater than or equal to, so I am going to have a filled in circle here. And then I want my variable, so I always read from my variable greater than 16. So I'm going to shade in this way. I'm going to shade in a little bit bigger because I want to make sure that I can definitely see which side I'm trying to shade in. So I filled in my circle because I have the equal to as well. I'm shading in the whole way here and my arrow. Now I do want to find one problem. Let's do one more of these just because I want to review what happens if the variable ends up on the other side. So for this problem, I'm just going to divide by 6 on both sides. Divided by 6. I'm not dividing by any negative numbers, so I just end up with a -4 is less than or equal to t. Not too bad. Now I have to graph my critical number. And again, because I have the line underneath, this is going to be a filled in circle. If I was missing that equal sign underneath here, I would have an open circle. And now here, I want to make sure that I read this inequality from the variable. That's really important. I want my variable, my answers, my t, to be greater than or equal to -4. So I'm actually going to shade this way to the right because this is where my greater thans are. So that is what happens if I end up with my variable on the opposite side than what we are used to. So then the next step, or the next thing that we're going to take a look at, is compound inequalities. Let's go ahead and review what some of these number lines looked like when we just had individual inequalities. So here, number one, this would represent x is greater than 18. I don't want to have a greater than or equal to because I have an open circle. So just the greater than sign, no equal bar underneath because of the open circle. My critical number is 18, and it is going to be greater than because all of my answers, my shading, are bigger than 18. So for number two, I'm now going to have x is greater than or equal to, because I have a filled in circle, x is greater than or equal to negative 61. For number three, my critical number is negative 7, and because I have a filled in circle, I want my bar underneath, and because my shading is to the left, I'm going to have a less than symbol. So x is less than negative 7. Number 4, I have x. All right, over here, I just realized I misspoke. This should be x is less than or equal to negative 7. I believe I said that incorrectly the last time. So on number 4, I have x is less than 2. Since I have an open circle, there's no bar underneath the less than sign, and since my shading is to the left, I do have a less than symbol. So when I'm looking at solving multi-step inequalities, I'm going to look at those the same way I do an equation, unless I end up having to, at some point in my solving my equations, unless I have to find or multiply or divide by a negative number. So here I'm just going to add 5 to both sides. Okay, so let me take a second to kind of go backwards a little bit and review our steps. So the very first thing that I need to do is to look to see if I have any grouping symbols. The next thing that I need to do is to combine like terms if I need to. The following step would be to move my variables. Then I'm going to move my constants. And lastly, I would need to, in these multi-step equations, either multiply or divide to get the variable by itself. So these are the steps that in my head I am going through every time I see one of these equations. Do I have grouping symbols? No, not for this one. Do I have to combine like terms? Not for this one. Do I need to move my variables? Well, all my variables are already to the left, so I don't have to do that step. So now that's why I'm doing the +5 first, because in my order of operations, that is the first thing that I have to do. So I have 2x left here, and 17 plus 5 is 22. So then I get x is greater than 11. So I have 11 as my critical number. And I want to have an open circle because I do not have the bar underneath here representing the equal to. And because reading from my variable, I have x is greater than 11, I want to shade to the right, including my arrow to say that my answers will keep going to infinity. So looking at question number 6, I want to, looking through my steps, the first thing I want to do is subtract 15 from both sides so that my constants all end up on one side of the inequality. And I have a -7 is greater than 3x. And then if I divide that should actually be a -9. Then if I divide both sides by 3, I get -3 is greater than x. So then I can graph my critical number as a -3. Now be very careful. You need to read from your variable. I want to read from my variable and say that this is going to be, x is going to be less than -3. So open circle and then go to the left. I'm going to go ahead and leave some of these to solve when we are working together during our Google Meets. And then your homework is going to be on page 25. It's going to be homework EI2C.